Welcome to Trigonometric Graphs. This video is for grade 11 and 12. Okay, let's go through the given scenario. We're given two functions, g of x and f of x. F of x is the cosine function, and the cosine function is shifting to the right. Remember, if it's negative inside the bracket, that means it's shifting to the right by 30 degrees. And the g of x function does not shift, but it has an amplitude of 2. These graphs are drawn in the interval of negative 180 degrees to 180 degrees. So A and B are the x-intercepts of f, and we can see that. That is where the f function cuts the x-axis at A and B. The two graphs intersect or touch each other at C and D respectively, and we also told that those points are the minimum. So C is the minimum of the f function and D is the maximum of the f function. So let's go to the questions, but before we do, let's just do a little recap of our grade 10 work. We know that the normal sine function would start at 0, and the next point would be at 90, and then at 180, and then at 270, and will complete its cycle at 360. And the cosine graph, on the other hand, starts at the amplitude, but it will cut the x-axis at 90, then again at 180, that point is at 270, and we will also complete its cycle at 360. So it also has a period of 360. So now let's go to the questions. All right, question 1. We're being asked to write down the coordinates of A, this point here, and C. All right, so if we look at the cosine function, this is where the cosine function cuts the x-axis for the first time on the right-hand side. So if we go to the original cosine function would cut the x-axis at 90 degrees. Now, it has shifted by 30 units to the right. So if the original function would cut the x-axis at 90 degrees, and it has now shifted by 30 degrees to the right, that means it will now cut the x-axis at 120. Therefore, the coordinates of A will be 120 degrees, and of course y is 0, so 120 degrees and 0. Now the coordinates of C, to calculate the coordinates of C, we need to remember we were told in the information that that is the minimum of the f graph of the cosine graph. So that is the turning point of the cosine graph. And again, if we go back to the normal, and if we look to the negative side, you will see that the normal cosine graph has its minimum at x being negative 180 degrees. All right, so we have to factor in the... So then we say the normal cosine function would have its turning point at negative 180, but there's been a 30 degree shift. So negative 180 plus 30 will give us negative 150 degrees. Another thing, what about the y value? Remember, the y value will be at the amplitude. And we know that the amplitude of the cosine graph is 1. And at this point, it will be at negative 1. So the coordinates of C would therefore be negative 150 degrees and negative 1. Let's move on to question 2. For question 2, we are asked to determine the values of x, of course, within the given domain, where g of x is bigger or equal to f of x. We know that g of x will be bigger if it is above f of x. So g of x will be bigger if it is above f of x. So where is g of x above f of x? Remember, this is the g of x function. So at that point, until you get to c, you can see that the g of x is on top, so it's bigger. And again, it's bigger over there because it is again above the f of x function. All right, and from previous calculations, we know that that is negative 150 degrees. All right, what about this point? What about point? Again, remember D from the information that was given. We were told that D is the turning point, the first turning point of the cosine function. So if there was no shift, where would that turning point be? Of course, if there's no shift, then the turning point of the cosine function would be at 0, x being 0. But there's been a shift by 30 units, right? So because there's been a shift by 30 units from 0, that means that point is at x equals to 30 degrees. Now we can answer the question. We know that when g of x to the left, when x is smaller, or let me just write it this way. So when x is smaller or equal to negative 150 degrees, that's to the left. Or again, if x is bigger or equal to 30 degrees but smaller or equal to 180 degrees, then the graph of g is bigger. Let's go on to the next question, question 3. Question 3, determine within that interval where both g of x and f of x are increasing. All right, so we start from the left. All right, and if we start from the left, you can see that g of x is decreasing and f of x is also going down. But when we get to c, we see now that f of x is increasing, but g of x is still going down. It's only when we reach this turning point that when now g of x is also increasing, now you see g of x is also going up. You can see now that both graphs are going up. They are both increasing, they are both going up until we reach point D. After point D, then f is decreasing again. So the only points where both these graphs are increasing, it's from that turning point of sine until D. Okay. Of course, we know that D is at x equals to 30 degrees. Now the question is, what is the x value of this turning point? The turning point of sine x is, of course, the turning point of sine x is, remember the graph of sine x hasn't shifted. So the turning point will be at negative 90 degrees. So therefore, we will say both graphs are increasing when x is bigger than negative 90 degrees but smaller than 30 degrees. So both graphs will be increasing from there to there. Otherwise, one is increasing when one is decreasing. But the only interval where they are both increasing is from negative 90 degrees to 30 degrees. Okay, let's move on to question 4. Determine again within the interval. All right, so we have to determine within that interval where g of x plus 10 is smaller than f of x plus 10. Okay, what we want to do when we deal with questions like this, we just first want to start with where g of x is smaller than f of x. And then we're going to factor that shift at the end. We know there's a minus 10 shift. We'll factor that shift at the end. So where is g of x smaller than f of x? Okay, remember g of x is smaller than f of x when it is below f of x. So from C all the way to D, g of x is smaller than f of x because it is below f of x. All right, it is below f of x, so it's smaller. And from previous calculations, again, we know that that is a negative 150 degrees, and that is 30 degrees. Okay, so g of x is smaller than f of x in that interval. Okay, so we start there, but remember, this is not what they were asking. The question was, where is g of x plus 10 smaller than f of x plus 10? That means now we can factor in the minus 10 shift. So we take the negative 150 and then we minus the 10 degree shift. And again, on the right hand side, let's minus the 10 degree shift. So the solution be between negative 160 and 20 degrees. All right, let's go on to the last question now, question 5. Okay, so we're given a function of cosine. What is the amplitude? That's easy. The amplitude of this function. All right, so the amplitude is 2. That's easy. And then, of course, because there's no vertical shift, the range will be from minus 2 to positive 2. The period, we always look at the coefficient of x to determine the period. Now, the normal period of a cosine function is 360. And as you can see, the coefficient before the x is 1. So the period will stay 360 degrees. What about the shift? Remember, if there's a minus, then that means the graph is shifting to the right. So actually, we've got a 60 degree shift to the right. Okay, let's go on to the second function, the function of g of x. Here the amplitude is 6. Question is, on the range now, it gets a bit tricky because there's a vertical shift of minus 2. So what we do is we would write the range as per normal, going from negative 6 to positive 6. But now, because of that vertical shift, we can minus 2. So negative 6 minus 2 is negative 8. 6 minus 2 is 4. So that will be the range after the negative 2 shift. What about the period? The normal period of a sine function is at 360 degrees, and the coefficient of x is 2. So we divide by 2, and we'll find the period is at 180. And of course, when it comes to the shift, we know the shift is minus 2, so we can say 2 units down. Finally, we come to h of x, the tangent function. The amplitude is always undefined. Remember, there's no amplitude for the tangent graph. In fact, the range is it goes from negative infinity to positive infinity. So there is no amplitude for the tangent graph. It goes from negative infinity to positive infinity. Now, the period of the tangent graph is usually 180. But because the coefficient in front of the x is 3, it will repeat 3 times. So that means the tangent graph now has a period of 60. How is the graph shifted? It has shifted by 20 degrees left and 1 unit up. Thank you, grade 11s and 12s. Of course, if you like this video, then like it. Thank you.